Hi, I'm Jan Ozer. I'm meeting today with Mason Barron, CTO of Digital Harmonics, to discuss the AI components in this product, Keyframe, a pre-processing solution that the company claims can adjust video to better than source quality while cutting your bandwidth by up to 80%. According to FuboTV, Keyframe not only ensures visually stunning content, but also significantly lowers streaming costs, creating a win-win situation for Fubo. Thanks for joining me, Mason.
Oh, thanks for having me. Excited to talk.
Yeah, my pleasure. So let's jump in. Describe Keyframe for me. What does it do? How does it work with existing encoders and codecs? Is it live VOD or both? Give me those details.
Sure. Keyframe has two main jobs. It reduces bitrate required to send the same quality video across the net, and it also allows for increased video quality to recover problems and reconstruct the original source from degraded video.
How is it delivered? Product, service, or both?
It's a software product that we deliver, and it's just put into whatever the video pipeline or workflow that any of our customers need. We're just a bump in the wire that sits right upstream of the distribution transcoder.
Is that a separate computer, a separate server, or just a function in their transcoding server?
It depends how they're built out, but typically it'll end up being a separate server that's GPU enabled.
Okay, so it does take a GPU. It is executing on that AI locally.
Yeah.
Okay. What's the bold, what can it do for you statement? I guess you've already made it. Tastes great, looks better, takes less bandwidth. I guess that's kind of it.
Yeah, maybe a next level of detail below it. It'll take in broadcast video, either live or video on demand, so file-based or live streaming workflow. And in real time, it will increase the video quality, increase the color saturation and clarity, as well as performing what we'll call adaptive entropy minimization to make it encode easier. And whether that's AVC, H64, HEVC, VP9, AV1, VVC, or LCC EVC, we've demonstrated the ability to reduce bitrate by anywhere from 30 to 80%.
How do you price it?
We don't release our pricing, but it's available either in annual or perpetual licenses.
So being a bit more specific than you were just a moment ago, what are your main claims regarding increased compression efficiency and increased quality?
So they're kind of, in our case, one of the things that makes us somewhat unique is part of our strategy with regards to encoding efficiency, so reducing entropy so that the encoder can have a more efficient ability to deliver the same video quality at lower bitrate, is centered around our ability to enhance the video. So obviously, if you can anti-alias, if you can clean up the video and reduce some of the artifacts that produce as noise into the encoder, you can actually reduce the entropy while increasing the clarity of the video. So that was our fundamental tenet when we got started, and then it's just been, years of figuring out. It turns out to be an incredibly challenging problem to be encoder agnostic and be able to be upstream of the encoder regardless of what it happens to be, and still achieve that entropy minimization, achieve that ability to reduce the bit rate. And then as far as the quality goes, on the other hand, so first we're increasing clarity. And as I'm sure you know, AVC, you're going to trade bitrate for macro blocking, like blurry blocks. And in the case of HEVC and moving more into VP9 and AV1, you're trading bitrate for blur. Like they're going to really focus on it. And we've built and patented what effectively is the best closed form deblurring capability on the planet. And so given that, the ability to enhance the video and choose where we do the enhancements has yielded a much better control over how the bitrate is used when pushing it down the wire. And we're able to do that completely arm's length without having to integrate anything specific with any given encoder.
Okay, so you talked about 80% before, you talked about 50 to 60%. How are you measuring that? Is that VMAF, PSNR, SSIM?
So yeah, typically it's going to be PSNR and mean opinion score. And we will use other references metrics like, PVQ or anything like that that's available based on however our customer likes to measure it. But at the end of the day, we use VMAF quite heavily. However, it tends to fall down in the motion category with regards to when you're really comparing two similar videos and trying to figure out which one is performing better. VMAF can be gamed in a way that you don't really see some of the motion artifacting that goes along. So we combine that with subjective evaluation, MOS, and that's typically our way that we evaluate it.
Okay, are there any independent third-party reviews beyond some of the customers that you have?
Just customers.
Okay. What about white papers? Any other published documents?
So we have white papers. One of the fundamental ones is usually when we go into a customer that likes to use PSNR or other like you mentioned, like any information-based metric, there's a level setting with regards to human perception is not really an information based measure. It's a perceptual one, and therefore it doesn't PSNR doesn't usually yield a direct measure of increased or lowered video quality. And so we have a white paper that goes into detail not using keyframe at all, not using any of our products, but just goes into detail showing a metric inversion that occurs in VMAF, PSNR, SSIM, and the rest of them, where you have a truly superior result being graded lower. And so we have white papers that are really just about level setting the video enhancement regime when you're trying to put it into an operational workflow, and then discussing how to measure it.
Are there any types of content that work particularly well or particularly poorly with keyframe?
I mean, certainly there's the falling confetti situation. There is a limit to what we can do upstream, and there's a limit to how much bitrate can be reduced. And certainly, if it's as you would imagine, this is probably obvious, but like if you're using cartoons, obviously those can be compressed incredibly well. So we tend to have to work when we give our numbers of the 30 to 60 or 30 80%. When we give numbers to a customer, we go demonstrate it. It's always on worst case scenario, because if you're like a Fubo where you have every type of content across sports, talking heads, you have cinematic, you have everything going through, there's only one setting there. So we have to set for the lowest common denominator, essentially the worst case scenario, and give our savings based on that, because hand tuning can't scale. And so it has to be adaptable, generalized, and it has to work. So as far as content that works together, it actually goes fairly hand in hand with the harder to encode things. If you think like a DERFS media collection and some of the very chaotic things that go on in there, some of the harder to encode segments are keyframe works in scale, right? So if you had easy to encode stuff, we're going to reduce 30%. In that same case, if you had a given target point of, like you were saying, like your VQ was somewhere in the 90 to 95% range, we're going to get you 30% reduction there. It's just off of a higher number because the video required it.
Right.
So we're kind of riding the difficulty to encode.
So let's start to focus on how you're using AI with keyframe. How do you start that process? I mean, do you start with a clean slate? Do you say we're going to target artifacts, or we're going to target noise and figure out how to minimize that? But, what's a development project like that look like?
Well, for us, so we started with the non-generative AI keyframe core product, which is, clarity increase, color expansion, and the bitrate reduction, the entropy minimization. So we started with that, and as I'm sure if there's a problem out in the world and you have an algorithm, now you have two problems, because it's getting it into an actual production pipeline and all the idiosyncrasies, all of the problem. That was all thanks to Fubo for growing us up and teaching us everything that we need to know when looking at 2,000 streams of every type of content imaginable from all content providers, and no standardization whatsoever, and how all of that goes through. But that was really the impetus for us when we started hooking up to hundreds and hundreds of streams and watching the tremendous variability in video quality and degradations that occur in modern cable and OTT broadcast. We realized that is what drove us to realize that our existing algorithms can only do so much to reconstruct. They can't do what generative AI can do. So then we moved in and we started training. Yeah, we started with de-artifacting, denoising, de-blocking, anti-aliasing was a big one, obviously upscaling, and those all came together. We wanted to build them into a single model, but our North Star has always been, we need to be sub 30 milliseconds door to door. We need to be able to handle 1080p 60 real time, 4K 60 real time. And so we were always building it with the mindset of, how do we make this work on live linear TV? How do we make this work with low latency and just be that true bump in the wire? And that was our North Star that drove us for our model selection as we advanced the model and kept moving it. And thankfully we had a customer that was very well versed in what their content looked like, and they were able to give us that MOS of they would run it through subjective evaluations, and they would run it, because it is a tremendous problem when you're putting significant enhancement in the pipeline like generative AI can do. What's your reference? Because the source is no longer your gold standard. And in fact, you're bringing this in specifically to fix the source's problems. So it's in all the reference-based metrics, it becomes, as you mentioned, it's extremely challenging, because you essentially have this, grade C test as the source, and you're trying to grade an A student based off it. Now that A student might have gone off the rails, but it just becomes very challenging. So early on, we used a lot of subjective analysis, and then once we built the trust in the algorithm itself, we started to actually use that as the reference to measure the source and do it bidirectionally. But it was driven heavily by just watching Keyframe Core and watching the limitations and how much it could push poor sources is what drove our move into generative AI and building Keyframe Boost.
Okay. What does that look like in terms of, what's the typical clip length? What's the typical resolution? Are you doing things with different rungs on the encoding ladder? How many clips did you test? How many subjective evaluators were there? What is all, give us a quantization of that effort.
Okay. Well, on our side, so we do our own independent, or I guess dependent evaluation, but we do our own independent evaluation of everything that we build. And we tend to have, as you can imagine, modern neural nets, even the compressed ones, need a significant amount of data to achieve generalization and to not have negative artifacts and to achieve high performance. We would subjectively evaluate that amongst our company as a whole, and then we would also, our customers would run internal subjective evaluation amongst other video engineers, and they would loop in a bunch of people in the company who weren't video engineers just to get that layman's people. Everybody knows what good video looks like, so to get them to do the A versus B comparisons. And so it scales into the tens of people evaluating each clip as we would move forward. But at the end of the day, it probably always boils down to a couple golden eyes taking a look at it and giving it the thumbs up versus thumbs down on any given clip.
How many clips did you look at, and what was the typical duration?
It really depends on obviously the temporal redundancy of the clip. Like if it's just one long shot, then there's a lot less value in taking repeated clips. But we're a huge fan of 5-minute videos as our that gets us, and if we can straddle a commercial, if we can straddle a bunch of other different scenes, different cuts during that, so that we can pull it, and then just a significant amount of hand tuning. But the number of clips we looked at, it's in the hundreds, because we have to cover everything from cartoon to cinematic to talking heads to high motion, and the various different. And obviously, as you can imagine, as we fielded this and as we encountered more and more video types, we would use VMAF as a kind of a quick check. We could run it through a massive amount of data, and it would give us the blips that would at least tell us you need to go look at this video. So we were able to build in more and find our edge cases, and then perform the fine tuning and do all the things we needed to do, and then build up our data set. But it sits in the hundreds right now.
What about the encoding ladder scenario? Did you look at multiple resolutions, multiple frame rates in some cases?
Oh, absolutely. So our customers are all adaptive bitrate ladders, and so we have to do our testing. And in some cases, they're running 4 or 5 different ladders within their delivery scheme. And so we've had to run Keyframe, both core and boost, across the entire ladder from 1080p 60 at full bit rate all the way down to 240p at a couple hundred kilobits a second. And so we had to measure it and make those recommendations. That's typical for how we go engage a customer. Yeah.
So let's look at this on a more granular level. What happens when you're actually training the algorithm?
So early on, it was about, well, obviously, everything in machine learning is selecting the right loss function, right? So that was really early on, trying to figure out the thing that would allow, because historically you're going to see PSNR, you're going to see some sort of perceptual loss, those kinds of things. And early on, we discovered the shortfalls in the traditional loss mechanisms that were available to us, and as it pertains to actual perceptual video quality and human, I guess, canniness would be the way, like non-artificiality, naturalness in the video. And so we spent a lot of time tuning. So it really was that case where you would train it up and go through several epochs and then review the test set visually to figure out what was slipping through the cracks, what was not being optimized, and then go revisit the loss function, figure out exactly what needs to be important, and how that have the tide raise all ships, as opposed to having a loss function for cartoons and a loss function for sports content and all those kinds of things. We needed the one to rule them all. And so that was a slow going, where it really was that iterative process you describe of going through, looking at one data set at a time, seeing how our improvements affected it, and then revisiting. In a lot of cases, we had to revisit the model architecture. And in some cases, it was just improving the loss function or adding data. Like that's the three things that we play with constantly are model architecture, add data to the data set, remove data from the data set based on redundancy or based on damage. And then also, or if something's overrepresented in the data set, that can be just as damaging as not having it in there at all. And then lastly, looking at the loss function, understanding how we train this thing efficiently and with high confidence that it's going to be generalized.
So how long did this entire effort take? Are we talking months, years, decades?
So the keyframe has been years, but Boost actually we went from initial idea to fielded operational capability in less than 6 months. And
Wow.
we've gone, yeah, and it's been 6 months since the first version of Boost came out, and we've had 4 versions since then. And we're about to release, we say we have 4 versions, but we're about to release V3 because a couple of those were just fine tunes. But we're about to release V3 that increases the density, can handle 1080p 60 on a single GPU, and runs in real time with no nasty artifacts or creating artificialness in the video. Because that's the biggest challenge with generative AI that we've found across all the models that we've worked with, is always having it produce artificiality in the content. Like human faces become overly smooth, things just start to look unnatural. Not unlike when you go a high refresh rate on a TV, right? You always turn that off first because it just makes things look uncanny. And so we spent the predominance of our time fine-tuning our model architecture, fine-tuning our loss functions and our data sets to avoid that, because it just has to look natural. It has to be perfect across all the content types. So building the model and getting it ready and doing those kinds of things is really the smallest amount of time possible. And then it's just the arduous fine-tuning of figuring out exactly how to make sure that it looks natural. That's where we spend most of our time now.
Looking at the source improvement function, how do you take into account creative intent, particularly regarding color, or I guess film grain, or anything really?
Absolutely. Well, and I mean, there's certain things that you are just can't be done. Like you don't change hue, you don't overly change saturation to the point where it becomes cartoonish or any of those kinds of things. But what we find, it means a lot to us that no one, when doing the mean opinion, like when doing subjective evaluation, that no one has ever come back to us and said, I don't like what you did, or it doesn't look right, or something's broken. That's like kind of our North Star there. And I always joke that there's really only 2 people that know what the creative intent was, and then there's 100 million people that are going to watch it. And so we err on the side of the 100 million as opposed to the 2, deeply upset them. But at the same time, we're if anything, the thing that our color enhancement does, and it's your question's perfect, because that's like the most, like, you could do a lot of things to video and only some of them should be done. And so we focus heavily on we find that a lot of broadcast content, a lot of film content has a kind of I don't want to call it a sheen, it's more like a haze attached to it, where it's just not using it's not even using the BT709 color gamut. It's not even using the stuff that SDR can handle. And in some cases that could be artist intent. In most cases, it's just something went awry in the color grading. I don't know. But yeah, we try to be judicious in our enhancement, and it is controllable. So the customer at the end of the day selects how far, whether they want to go to 11, and that's on them.
So you've got 2 basic functions. You've got core, which delivers compression efficiency, and you've got boost, which boosts visual quality. How are each of those functions scalable in these bump in the wire servers that you're talking about?
Oh, sure. So in a given server that has, say 5 GPUs in it, probably costs around 20, 25 grand, you're going to get anywhere from 55 to 85 core services. So streams, channels going through it, you're going to get about 55 to 85 of those in real time. And that one server will be able to handle. As far as boost goes, that's going to be 1 to 2 per GPU. So you may only have 5 or 10, but that's really driven by the density there, is made okay by the fact that you don't need boost on every single channel. You don't need boost on 2,000 channels. You need it on 25, 50, something like that. So the scaling ends up working out where you have the predominance of your processing is running through core, and you just use boost where it's needed for recovering bad feeds or enhancing even more. Some people just really like They just want the max on specific channels. And so who are we to argue?
So what's the typical allocation usually between boost and core? 95/5, 80/10, or 80/20?
I think 90/10. 90/10 is probably about the right as a percentage.
And just to be clear, so it would be 10% gets both core and boost?
Yeah, exactly right. So boost encapsulates core, so you get both the bit. You can actually get further bitrate reduction if you're in a pinch. In a lot of cases, as you can imagine, removing all of the aliasing, removing all the blocking, all the problems makes it much easier to encode. And so we achieve an even greater bitrate reduction in the boost cases often. And so yeah, 90% would be core, and 10% would be the combination of boost and core.
Is the problem you're solving more prevalent in live OTT services as compared to, I mean, Netflix, they get their most of the content in very, very high quality format, but a lot of these services are getting live 10 megabit per second streams that have been encoded multiple times. Is your service, more targeted towards those type of applications, or, the high quality premium content of VOD type services?
So in the case where you have like a Netflix or an Apple TV Plus, especially like the MLS streams that go along with Apple TV Plus, where you have really high quality sources coming into the OTT provider, and then you have their ability to spend time with it, especially if it's VOD, they can take their time and do multipass encoding. They can gain a lot of gains. Boost, I would assert, would be less prevalent in those cases, still applicable in a lot of the source content, because there is still variability in the quality of the sources, especially when they start pulling back catalog of videos not from this decade. There's a huge value to boost in those cases. But typically what you're going to see there is the predominance of our value to those use cases would be core, where when they're encoding an AV1, we can take them another 40% less in bitrate and reduce their storage and egress costs and reduce the network as well. Networking.
Okay,
Impact.
so core is going to apply to any video irrespective of the origination quality.
Right, but as you said, if you're getting it straight from the production house and it's pristine and color graded already, there's a lot of cases where boost is just overkill.
Okay, got it. Listen, Mason, that's it. Thanks for your time.
Oh, thanks for having me. It's great.